Hello, we are from Group 5. I am the first one to present. My name is Ming Jian. So our project is energy efficient fan controller. For introduction, because in a tropical nation like Malaysia, where the afternoon suns are very hot and then cooling is not a luxury. So it is necessary, whatever it is in sport hall or waiting hall or public area, there will be a fan continuously functioning, which is very energy inefficient, and then this will cause a lot of pollution in our world. So this kind of always on is in our public spaces create a significant problem for Malaysia's sustainable goals. So the nation energy policy for 2022 to 2040, the challenge is no longer just about generating more power, but about eliminating the wasted power. So our solution is that our energy efficient fan controller is a smart system designed to reduce unnecessary electrical usage in public areas such as cafes, parks, waiting areas, and halls. The system uses a sensor such as a motion or presence sensor to detect whether people are nearby or in that area or not. So when no movement or presence is detected, the fan will automatically turn off, preventing energy wastage. When a person enters the area, the fan will turn on automatically, so it will reduce the operating costs, support the environmental sustainability throughout the efficient power usage.
So I will present about the benefit of prototype. So the first benefit is active presence-based automation. So unlike the traditional fans that require a human to flip a switch and often stay on long after the person has left, this system features active presence sensing. The fan does not just detect movement, it detects the presence of an object within a defined distance, ensuring that cooling is only provided when a user is physically present to benefit from it. Second, intelligent energy saving. This feature addresses the primary issue of energy waste in empty halls and cleaning. Once the ultrasonic sensor confirms the error is vacant, it triggers a time shutdown sequence. This ensures the motor is not cutting off abruptly if a person moves slightly out of range, but prevents the fan from running for hours in an unoccupied space. Third, mechanical longevity protection. By reducing the total time functioning of the fan by an estimated 40 to 60%, the system significantly reduces heat build-up in the motor coils. This innovative approach moves the focus from repair and replace to preserve and protect, effectively doubling the operation lifespan of public cooling hardware.
Now, my name is Zhi Jien. I'll be talking about the prototype construction of our project. So the list of components that we will be using are ultrasonic sensor, a 9-volt battery and battery holder, an Arduino Uno, L293D motor driver, a straw board, breadboard and jumper wire, fan blade, and a DC motor. So the controller of the project is the Arduino Uno. It will act as the system's brain. It will constantly run the code that makes the decisions based on the data it receives. The input for the Arduino Uno is the ultrasonic sensor, which serves as the sensor for the fan. The sensor will sense whether there is objects at the designated area, so that it will know if a person or an object is there. The Arduino then measures how long it took for the sound to return. This causes the Arduino to know that someone is there and decides to trigger the fan. Due to the Arduino itself, it cannot provide enough electricity to spin the fan motor. The Arduino have a 5-volt power supply that can only provide the electricity enough to power the logic system of the L293D motor So we will connect an external power supply to drive the motor. When the Arduino detects a person, it will send a low power signal to the L29 3D. The L29 3D then opens for the stronger current from the 9-volt external battery to flow into the DC motor. This separation is crucial because it protects the delicate Arduino from being damaged by the high power requirements of the fan motor. All the components are bridged together using a breadboard that acts as a base and allows the electricity and data signals to flow between the sensor, the board, and the power source without needing a permanent solder. The final output is the fan propeller attached to the motor shaft. The system ensures that the 9-volt battery only drains energy when the ultrasonic sensor confirms an object or a human is present, effectively turning a standard fan into an intelligent, eco-friendly fan.
So my name is Kai Zhe. Now I will demonstrate our prototype.
So this is our prototype. Our prototype is built based on the scenario at coffee shop. So basically when in coffee shop nowadays, the fan is keep turning on whether there are people or not. So it will waste many energy to our end and cause pollution to our earth. So our prototype has solved this problem. So basically our prototype is using a ultrasonic sensor to scan whether there are people at there. So when people are there, the fans will turn on. So when people are not at there, the fan will auto close it to save energy.
My name is Zhi Jien and I will be presenting about the prototype functionality demonstration. My name is Zhi Jien and I will be presenting about the analysis and output of prototype. So this project is more than just a combination of sensors and code. It is a thoughtful response to the unique environmental and social landscape of Malaysia. By addressing the silent issue of energy waste in public clinics, transit hubs, and community halls, we are proposing a shift in how we interact with our shared resource. We often overlook the humble wall fan, yet it is an important infrastructure in the Malaysian comfort. We can use accessible technology to solve the always-on habit that drains our economy and our environment. Ultimately, the success of this present sensing fan lies in its human-centric design. It honors our commitment to a greener future by cutting unnecessary carbon emissions. As we move toward a smarter nation, solutions like this remind us that innovation is most powerful when it is practical. By ensuring that a cooling breeze is provided exactly when and where it is needed, we create a public space that is not only more comfortable for the citizens, but also more responsible towards the planet we call home.
For implementation, we suggest two things. First, integration with temperature-based control. While presence sensor save significant energy, combining with the temperature sensor such as the DHT11 or DHT22, add a new layer integrity. Dynamic speed adjustment. The fan could automatically adjust its speed based on the real-time event temperature. It's like faster when it above 30 degrees and slower during rain and or early morning. Automatically expectation. If the temperature falls below the comfortable threshold at 24 degrees, the fan could remain off even if presence is detected, feature maximizing energy saving. Second thing is the IoT implementation for remote monitoring. Moving toward Industry 4 standard in Malaysia, this system could be upgraded with the Wi-Fi enabled monitor, like the Node MCU ESP2260 or ESP32. Real-time analytic factory management with monitor energy concentration and asset patterns in public space via mobile app or web dashboard. Remote mine testing. The system could send notification if the
alteration should become blocked or if the motor requests sharing.
That's all from us. Thank you.